were going to start the chapter 10, that is electric current and its effect. You might have tried the game How Study in Your Hand, suggested in chapter 9 of class 6. If not, you may try it out now. Paheli and Bujo had also set up game by connecting an electric circuit as suggested in class 6. They had a lot of fun trying it out with their family and friends. They enjoyed it so much that they decided to suggest it to a cousin of theirs who stay in different town. So Paheli made a neat drawing showing how the various electric components were to be connected. Can you draw the circuit conveniently? If it made Bujo wondered if there was an easier way to represent these electrical components. Some common electrical component can be represented by symbol in table 10.1. Some electric component and their symbols are shown. You may come across different symbols from these component in different books. However, in this book we shall be using the symbol shown here. Look at the symbol carefully. In the symbol for the electric cell, notice that there is a long line and a shorter but thicker parallel line. Do you recall that an electric cell has a positive terminal and a negative terminal? In the symbol of the electric cell, the longer line represents the positive terminal and the thicker and shorter line represent the negative terminal. For a switch, the on position and the off position are represented by the symbol as shown. The wires used to connect the various components in a circuit are represented by lines. In table 10.1, a battery and its symbol are also shown. Do you know what a battery is? Look at the symbol of a battery. Can you make out what a battery could be? For some of the activities, we may need more than one cell. So we connect two or more cells together as shown in figure 10.2. Notice symbols for some electric circuit component. Electric component and their symbol. Electric cell which is represented by this. Electric bulb which is represented by this symbol. Switch in on position is represented by this symbol. Switch in off position is represented by this symbol. Battery is represented by this, and wire which is represented by this. That the positive terminal of one cell connected to the negative terminal of next cell, such a combination of two or more cells is called battery. Many devices such as torch, transistor, toy, TV control, remote use batteries. However, in some of these devices, the electric cells are not always placed one after the another as shown in figure 10.2. Sometimes the cells are placed side by side and then how the terminal of the cell connected. Look carefully inside the battery compartment of any device. There is usually a thick wire or a metallic strip connecting the positive terminal of one cell to the negative terminal of the next cell. Figure 10.3. In order to help you to place the cell correctly in the battery compartment, positive and negative symbol are usually printed there. How can we connect the cell to parallel prepare battery for our activities? You may make a cell holder as shown in figure 10.4, usually a wooden block, two iron sticks and rubber band. It is necessary that the rubber band holds the metal strip tightly. You could also buy cell holders from the market for making batteries of two or more electric cells. Place the cell in them properly such that the positive terminal of one cell is connected to the negative terminal of the next cell. Connect a piece of wire each of the two metal clips on the cell holder as shown in figure 10.5. Your battery is ready for use. The symbol used for representing a battery is shown in table 10.1. Let us now draw a circuit diagram of electric circuit using symbols in table 10.1. Activity 10.1. Make the electric circuit shown in figure 10.7. You should use a similar circuit in class 6 to make an electric bulb glow. Do you remember that the bulb glow only when the switch is in the on position? The bulb glow as soon as the switch is in the on position. Copy this electric circuit in your notebook. Make also a circuit diagram on this circuit using symbol for the various electric components. Is the diagram similar to shown in figure 10.8? It is much easier to draw a circuit diagram using symbol. Therefore, we generally represent an electric circuit it's by circular circuit diagram. Figure 10.9 shown another circuit diagram. It is identical to the circuit diagram shown in figure 10.8. In which way it is different? Would the bulb glow in this electric circuit? Recall that the bulb glow only when the switch is in the on position and the electric circuit is closed. Paheli and Bujo wonder whether the batteries used in tractor, trucks and inverter are also made from cell. Then why it is called battery? Can you help them to find out the answer to this question? Notice that the key or switch can be placed anywhere in the circuit. When the switch is in the on position, the circuit from the positive terminal of the battery to the negative terminal is complete. The circuit is said to be closed and the current flowing through the circuit instantly. When the switch is in the off position, the circuit is incomplete. It is said to be open. No current flow through any part of the circuit. In the bulb, there is a thin wire called the filament which glow when an electric current passes through it. When the bulb gets fused, its filament is broken. Caution: never touch a lighted electric bulb connected to the mains. It may be very hot and your hand may get burned badly. Do not experience with the electric supply from the mains or generator or inverter. You may get an electric shock, which may be dangerous. Use only electric cell for all the activities suggested here. If the filament of the bulb is broken, would the circuit be complete? Would the bulb still glow? You might have noticed that the glowing bulb, electric bulb, become warm. Do you know why? 10.2 Heating effect of electric current. Activity 10.2. Take an electric bulb, a cell, switch and connecting wire. Make an electric circuit as shown in figure 10.9. This activity has to be done using only one cell. Keep the switch in the off position. Does the bulb glow? Touch the bulb. Now move the electric switch to the on position and let the bulb glow for a minute or so. Again touch the bulb. Do you feel any difference? After moving the switch back to the off position, touch the bulb again. Activity 10.3. Make a circuit as shown in figure 10.10. Take about 10 centimeter long piece of nichromium wire and tie it to the nail. Tie it between the nails. You get you can get nichromium wire from an electric repair shop, or you can use a piece of discard coil of an electric heater. Touch the wire. Now switch on the circuit in the now switch on the current in the circuit by moving the switch to the on position. After a few seconds, touch the wire. Do not hold it after a long time. Switch off the current. Touch the wire again after a few minutes. Caution: do not keep the switch in the on position for a long time. Otherwise, the cell may become weak very quickly. The wire gets hot when electric current passes through it. This is the heating effect of the electric current. Can you think of any electric appliances where the heating effect of electric current is used? Make a list of such appliances. You might have seen an electric room heater or electric heater used for cooking. All these contain a coil of wire, and this coil of wire is called an element. You may have noticed that when these appliances are switched on after, Pujo could not see element in an electric iron. Paheli told him that electric appliances such as immersion heater, hot plate, iron, geyser, electric kettle, hair dryer have elements inside them. Have you ever seen the element in any appliances? Connected to the electric supply, their element become red hot and give out heat. The amount of heat produced in a wire depends on its material length and thickness. Thus, for different requirements, the wire of different material and different length and thickness are used. The wire used for making electric circuit do not normally become hot. On the other hand, the element of some electric appliances become so hot that they are easily visible. The filament of incandescent electric bulbs, figure 10.12, are often used for lighting, but they are also give heat. It means that a part of electricity consumed in using is used in producing heat. This is not desirable as it is the result of wastage of electricity. The fluorescent tube light and compact fluorescent lamp (CFLs) are better electricity efficient lighting source. Nowadays, the use of light emitting diode LEDs bulb is increasing. For producing a given intensity of light, LED bulbs consume less electricity as compared to the incandescent bulbs are fluorescent tube or CFLs. Thus, LED bulbs are much electricity efficient and then being preferred. It is advised to use electric appliances and gadgets which are electrically efficient. Bureau of Indian Standard New Delhi assigned a standard mark on products called ISI mark. This is the ISI mark, which is an assurance of conformity to the specification given on the product. It is therefore suggested to use ISI mark product. Note: fluorescent tube and CFLs contain mercury vapor, toxic in nature. Therefore, damaged fluorescent tubes or CFL needs to be disposed of safely. An electric bulb gets heated to such a high temperature as it starts glowing. If a large current passes through a wire, the wire may become so hot that it may even melt or break. But it is possible for wire to melt and break. Let's check it out. Activity 10.4. Make the circuit be used for activity 10.3 again. However, replace the cell with battery of 4 cells. Also, in place of the nichromium wire, tie a thin strand of steel wood. The steel wood is commonly used for cleaning utensils and is available in grocery shop. If there are any fans in the room, switch them off. Now pass the current through the circuit for some time. Observe the standard of steel wool carefully. Note what happened. Does the standard of steel wood melt and break? Wire made from some special material melt quickly and break when large electric currents are passed through them. These wires are used for making electric fuse. In all, building fuse are inserted in all electric circuits. There is a maximum limit on the current which can safely flow through a circuit. If by accident the current exceeds this safe limit, the wires. Caution: never try to investigate an electric fuse connected to main circuit on your own. You may, however, visit an electric repair shop and compare the burnt out fuse with new ones. One reason for excessive current in electric circuit in the direct touching of wire. This may happen if the insulation of the wire has come off due to wear and tear. This may cause short circuit. Another reason for excessive current can be connection of many devices to a single socket. This may cause overloaded in the circuit. You might have read report in newspaper about fire caused by short circuit and overload may become overheated and may cause fire. If a proper fuse is there in the circuit, it will blow off and break the circuit. A fuse is thus a safety device. These days, miniature circuit breaking (MCBs) are increasingly being used in place of fuse. There are switches which automatically turn off when the current in a circuit exceeded the safe limit. You turn them off, you turn them on, and the circuit is once again complete. Look for ISI mark on MCBs also. Caution: always use proper fuse which been specified for particular application. Carry ISI mark. Never use just any wire or strip of metal in place of. Prevent damage to electric circuit and possible fire. Fuses of different kinds of used for different purpose. Figure 10.14 shows fuse used in our houses. Fuse shown in figure 10.15 are generally used in electric appliances. We observe the heating effect of electric current and learned how we use it our advantage. Does the electric current have other effect also? Magnetic effect of electric current. Activity 10.5. Take the cardboard tray from inside the discarded matchbox. Wrap an wire a few times around the cardboard tray. Place a small compost needle inside it. Now connect the free end of this wire to an electric cell through a switch as shown in figure 10.17. Note the direction in which the compass needle is pointing. Bringing a bar magnet near the compass needle, observe what happened. Now, while watching the compass needle carefully, move the switch to the on position. What do you observe? Does the compass needle deflected? Move the switch back to the off position. Does the compass needle come back to its initial position? Repeat the experiment and few times. What does this experiment indicate? We know that the needle of a compass is a tiny magnet which points in north-south direction. When we bring a magnet close to it, the needle gets deflected. We have also seen that compound needle get deflected when the current flowing in a nearby wire. Can you connect the two observations? When the current flow through a wire, does the wire behave like magnet? This is what a scientist called Hans Christian Ørsted, figure 10.18, also wondered. He was the first person who noticed the deflection of compass needle every time the current was passed through the wire. So, when electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of electric current. In fact, an electric current can be used to make magnets. Do you find it too surprising? Let's try it out. Remember not to switch on the current for more than a few seconds at a time. The electromagnetic weakens the cell quickly if left connected. Electromagnet. Activity 10.6. Take around 75 centimeter long piece of insulated plastic or cloth covered enameled flexible wire and an iron nail, say about 6 to 10 centimeter long. Wind the wire tightly around the nail in the form of coil. Connect the free end of the wire to the terminal of the cell through a switch as shown in figure 10.19. Place some pin on or near the end of the nail. Now switch on the current. What happened? Do the pins cling to the tip of the nail? Switch off the current. Are the pins still clinging to the end of the nail? The coil in the above activity behave like a magnet when electric current flows through it. When the electric current is switched off, the coil generally loses its magnetism. Such coils are called electromagnets. The electromagnets can be made very strong and can lift very heavy load. Do you remember the crane about which you read in chapter 10 of classics? The end of such crane has a strong electromagnet attached to it. The electromagnets are also used to separate magnetic material from junk. Doctor used tiny electromagnets to take out small piece of magnetic material that have accidentally fallen in. The eye. Many toys also have electromagnetic magnets inside. Electric bell. We are quite familiar with an electric bell. It is an electromagnet in it. Let us see how it works. Figure 10.20. Show the circuit of an electric bell. It consists of a coil of a wire wound around on an iron piece. The coil acts as an electromagnet. An iron strip with a hammer at one end is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in contact with the screw, the current flows through the coil, which becomes an electromagnet. It then pulls the iron strip in the process of hammer at the end of the strip, striking the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip, it also breaks the circuit. The current through the coil stops flowing. Will the coil remain an electromagnet? The coil is no longer an electromagnet. It is no longer attract the iron strip. The iron strip come back to its original position and touch the contact screw again. This completes the circuit. The current flow in the coil and the hammer striking the gong again. This process is repeated in quick succession. The hammer striking the gong every time the circuit is completed. This is how the bell rings. Summary. Wire made from some special material melt quickly and break when a large electric current passes through them. And these materials are used for making electric fuse which prevent fire and damage to electric appliances. When electric current flows through a wire, it behaves like a magnet. A current carrying coil of an insulator wire wrapped around a piece of iron is an electromagnet. Electromagnets are used in many devices. Do you know the credit for the invention of an electric bulb is usually given to Thomas Alva Edison, though others before him and worked on it. Edison was a remarkable man. He made some 1300 inventions, including the electric bulb, gramophone, the motion picture camera, and carbon transmitter, which facilitated the invention of the telephone. This is Thomas Alva Edison, AD 1847 to 1931. That's all for this chapter. Do share this summary to your friends so that I can make more such videos.